So let's look at some strategies. We're doing these in a simplify the way it looks. And especially if you're dealing with some cation or some trig, you might be able to do some modifications to make life a little bit easier. So for example, I'm not going to go through the actual solving of these, but at least the setup. And so for something along these lines, you might be tempted to automatically look at it and say, oh, we're multiplying two things. Let's use integration by parts. But instead, if you just do some distribution, you can now do a power rule twice. Straightforward. When you're given something along these lines, is not necessarily going to work. There's a fraction, so things look a little bit ugly there. But if you change everything into sines and cosines, this would be a sine over cosine for the tangent. And then the secant squared is a 1 over cosine squared. But since it's on the bottom, this just becomes a cosine squared. Cosines will cancel. And you're left with an integral of a sine times cosine. Now you could either use your double angle formula to make this a 1/2 sine of 2 theta, or this is now set up for a real nice u substitution, where that could be your u, there's your du, or even there's your u and there's a negative of your du. So very straightforward and a lot nicer than what the initial looks like. If you would have this cosine plus sine all squared. If you go ahead and do your foiling, you recognize that your cosine squared plus sine squared is just a 1. And now you have another easy integral to do. That one's straightforward. This is just like what we did before of doing your u substitution, or you could make that just a sine of 2x, and then that's a very simple u substitution if you even need to do it that way. So you could handle it. Other ones, always look for u substitution. If you can do u substitution, that's going to be your simple, well, one, just try to do it like we did up above, maybe even with a little bit of simplification. Or two, u substitution. Can you identify a specific u where you're going to have that du somewhere in your problem? So here, this bottom is a very nice u. Derivative of an x squared is going to give you something that involves an x. Okay, you can do it. If it can't be just a methods, Does it resemble a setup of anything else we've done? So is it just dealing with your trig functions? So having our trigonometric integrals. Just multiplying sines and cosines with different powers. We know how to handle that. Are you multiplying your tangent and secants with different powers? We can handle that. Are you multiplying your cotangents and cosecants with different powers? Okay, we know how to do those. Is it going to be trigonometric substitution? In which case we want our x to be secant. Is it a situation where we have an x squared plus 1 or 1 plus x squared? In which case we want our x to be a tangent. Is it a situation where x to equal sine? So recognizing any of these three situations that you have in there, if your strategies from before aren't going to help or aren't going to be productive, and again, if it's not a 1 there, you might have to put a constant in front and then evaluate. Are you dealing with polynomials? Specifically, polynomials that have fractions, so rational functions, in which case you can do your partial fractions. That has something that can be broken down into an x plus something, an x minus something, whatever it's going to turn out to be. Whatever you got on top. Or if this is a squared on the bottom, whatever, you know your different strategies for how to break that up. In this case, it would be an integral of an ax plus b over our x squared plus a plus our c over x minus. And then use your partial fraction stuff to try to solve for your capital A, your capital B, and your capital C. And then hopefully you can do these integrals in a little bit more straightforward manner. But splitting up to have addition or subtraction between fractions is a lot easier than doing multiplication between fractions. Do you, where you could make one of those integration. That's going to be your f times your g minus your integral of your g So multiplication of two functions. If some of the other methods before don't work, try your integration by parts. Most people try and do this a little bit farther down the line because it can be a little bit more longer and more cumbersome. And if you can do just a straight U substitution, that's going to be your best bet. But if that fails, integration by parts. Again, we're not necessarily it's nice if all the or evaluate these integrals. We want to be able to get answers from them. If it happens to be a long, cumbersome process, it's a long, cumbersome process. But we're looking to get results here. It's not always going to be easy, but we want to be able to get results in some way, shape, or form. Another way is dealing with radical or other categories that we listed above. And then your final thing, try again. You know, the old saying is if you don't succeed, try again. Thomas Edison, the guy who well, didn't invent the electric light bulb, but he came with the filament that, worked a bit better and popularized it and helped to sell and everything. He had a saying that was, I have not failed. I just found 10,000 ways it won't work. So he didn't succeed right away with everything that he did. And you can say what you can relationship with Tesla and all that, but the idea of even though you don't succeed right away, that's okay. You've now learned something from having your method not work. Being able to learn from that of, okay, here's a situation, here's a method that might work for it. Oh, wait, it doesn't. Okay, now you know that you need to use something else. And next time you're presented with a similar situation, hey, let's not use that method. Let's try and use this other one. So all of this is a learning experience. And so having a situation not from things that don't work out, and you can really often learn why they didn't work, not just that they didn't work. And then in that process, you often learn why something else will work, not just that it does work. So the trial and error, the discovery process is actually a good thing. So when you're working through them, try integration by parts, try to manipulate things and simplify. You might have to use several methods combined together. So just keep all of this in mind whenever you are solving integrals.